This video is going to go along with task sheet 840. We're going to get the oscilloscope out again and hook up to a couple more sensors. This time we're going to do an oxygen sensor test and one on the fuel injectors. So just more kind of showing you guys how we hook this up and what some different waveforms look like. In our task sheets, it's going to ask you to draw or print out our waveforms. Obviously you can't do that. If you guys can just kind of describe to me what a good waveform is going to look like, that'll do. But I'm going to get these hooked up and show you where to hook them up and what it looks like afterwards. So here we go. All right, so here is our main menu of our scope that we're using today. And again, just like last time, we're going to go into guided component tests. We're going to build out our vehicle. All right, so we've got our vehicle loaded and these are our options. So anything drivability related is going to be in the fuel injection menu. So we scroll down. The first one we're going to do is oxygen sensors. So we have a few options in here. We can test two sensors. We can do a heater test or single sensor tests. We're going to go ahead and go into single sensor tests, and there's actually going to be another menu in here. So we have a bench test, in-car, O2 response, and PCM response. Bench test is testing the sensor out of the vehicle in a vise. If you guys don't remember, oxygen sensors actually kind of generate their own voltage, so we don't need to necessarily have them hooked up to anything for them to start reading things. So we can test this out of the car, but it involves, and there's a few of these tests that involve using propane for the sensor to read. The in-car and the PCM response test, both of those involve, and the bench test, all those involve using propane to generate a signal out of the sensor. And the reason why they do that is they want, propane is going to be a substitute for our fuel. So if we want to make sure that our sensor and our PCM are responding correctly, we have to be able to manipulate the fuel somehow. And the way we can do that is by injecting some propane into the system. Now, this is something I've never done. I've actually never seen anybody else do it, but it is an option. Obviously, you're probably not going to have a lot of propane laying around in the shop, and there's some safety concerns that come along with you guys dumping a bunch of propane into a running vehicle. So, not a real common test, but it's out there if you need it. But we're going to go into an O2 response test. So it's already got our scale on the left set up correctly. If we pull up our information, we want to be in closed loop. We're going to scroll down. It's going to tell us kind of how to hook this up. Our yellow lead is going to go to our O2 signal. It's wanting us to go to 2500 RPM and look for the switches between 800 and 250 millivolts. So each system is going to be maybe just a touch different, but they should all be pretty close. So this kind of just gives us some more information about the test. We may want to snap the throttle and see a rise in voltage. Basically, we want to see the sensor respond to things that we're doing. As we go down, here's our pinout at our oxygen sensor itself. And we want to hook up to the O2 signal, which is going to be our purple wire. Again, it's easier for me to get to the PCM on this vehicle than it is for me to crawl around on the ground and try and tap into one of these. So we're going to go at the PCM, kind of like the other ones. But it's going to be the exact same thing as if we were hooking it up down at the sensor. It's still a purple wire down there. It's a purple wire up at the PCM. We're just going to tap up into it at the PCM just because it's a little bit easier for me to do. So we're going to get this thing hooked up and take a look at our waveform. All right, again, this is probably going to look kind of like the other ones. How we're hooked up, we're pierced into one of the signal wires, a purple wire at the PCM. And then we're at ground over here on our alternator bracket. So this is what our waveform's looking like. You guys remember O2 sensors switch high to low. So you can see that kind of in a visual way on this lab scope. And it just kind of gives you an idea as we're going rich to lean, rich to lean. And sometimes as this thing was warming up, some of these high peaks and some of the low valleys, they get real wide as this thing is really trying to dial in our air-fuel ratio. So this is normal. We want to, yeah, you see that one is a little bit wider than the rest. So it's still trying to kind of nail our air-fuel mix. So we can give this thing some more RPM to kind of tighten up a little bit. It should switch. See, it's switching a lot faster now. So it's kind of same with the other ones. We want to look for a nice kind of uniform pattern. This one is a little bit different since it's constantly changing based off what the PCM puts in it. You may see some differences like that one right there. It's not terribly out of the ordinary, but what we want to see is the switch high to low, high to low. And we can actually come over to our scanner and look at our data up here at the top. Bank 1 sensor 1 and bank 1 sensor 2. Yeah, all that you can see it kind of in the numerical format on our data display. These switching low to high, low to high. That's the exact same thing that we're seeing on the scope. So we can kind of use this information together to make sure that we're reading correctly and that our PCM is getting that information and interpreting it correctly. And I'm hooked up to sensor 1, I believe. The sensor 1, bank 1. Is what we're hooked to. Sensor 1, bank 2 should be the same. It should switch. Now our sensor 2s, bank 1 and bank 2 sensor 2s, those are our catalyst monitoring. So we want that to stay fairly even. These converters are pretty cold, so they're going to switch for a minute, but once they get warmed up and get functioning properly, you'll see our sensor 2 values kind of level off and stay even. But if we were warmed up to temp and those sensor 2 values are switching back and forth, just like the front ones, then we know we got a problem. But as you can see, our sensor 2s, the ones on the right, aren't switching quite as much as the ones on the left. They're not hitting that full range. That bank 2 maybe a little bit, but like I said, this thing needs to warm up a little bit more. But that's what we're looking for on oxygen sensor testing with the scope. Again, you can kind of see our pattern. May not be 100% uniform, but we want to see the switch is what we want to see. So I'll get this hooked up to a fuel injector next, and we'll see how that looks. All right, we're back to our main menu, and we're going to check out a fuel injector here real quick. So we go into our fuel injection system, and as we scroll through, we'll find fuel system. And then these are our options. We have level sensor, pressure, pump, and injector. So we're going to go into our injector. We have a few options here. We're going to go with the signature test again. That's just kind of our basic test, checking patterns on most of these sensors. We can also do a current ramp test. That's going to let us know what our amperage is going to each of our fuel injectors. We do that with an amp clamp. And I don't know if you guys remember from basic electrical what that is, but it's a clamp that goes right around the wire, and we can read amperage without having to tap into the circuit itself. Here's our amp clamp. I grabbed one from the school to go with this one with these tools. Apparently this one isn't working correctly. We do have a scale that you'll have to set depending on what you're testing. And of course, we got our clamp. You want your wire to go through that hole. Just keep in mind that there is a direction to this. So you want to make sure that your current flow is matching up with the arrow on the clamp. But like I said, we're going to do our signature test. So we are tapped into our wire over here. It wants to be on the control side, so we need to look at a diagram and see. Now it does tell us how to hook this up in the scope, but it doesn't tell us wire colors or anything, so we had to go to the diagram. I'll show you that here real quick. So if we look at our diagram here, we start up at the top, and we have injector fuses that run all of these from the underhood bus electrical center, which is the fuse box, and power is fed straight to the injectors. We see on the bottom we've got our powertrain control module, or our PCM. So our injectors are controlled on the ground side. So a lot of times this stuff is done on the power side, but for these injectors, the PCM is controlling ground. So these things don't do anything until the PCM switches ground on and off for these. So we need to be, I believe we're on injector 2, so we're on the light green with a black tracer is where we're going to tap in. So I'm going to get the truck started up and we'll take a look. So this is what our little waveform looks like. Remember, this is just one fuel injector at a time. So you see this dip down here, this is off. And then this is where we turn our fuel injector on. We need a little bit more voltage to crack this thing open. We got to overcome the fuel pressure, so that's why there's a little bit of a spike. But once it's open, we pulse width modulate these injectors, so it's like a super fast kind of on and off that gives us our pulse. So all right, this is on, off, and then back on again. So it doesn't really tighten up necessarily. I mean, it does a little bit when we give it some RPMs, but that's kind of what we're looking for. We want that nice kind of smooth on and then transition into our pulse. But again, we're just kind of comparing this to a known good waveform. Make sure we don't have any problems with this thing sticking or anything like that. So that's going to kind of wrap us up for fuel injectors. Fill out the sheets the best you can, and that's going to do it for today.